All right, this screencast is designed to just help give you a few hints on your reporting category 1 review, because I noticed that there were a few things that weren't pointed out in the review materials that I gave you. Now, some additional things have been posted in Google Classroom, and I do want you to look at that. All right, first, density is mass divided by volume. But if you needed to know the formula for mass, you just multiply both sides by V to move it, and mass is density times volume. Well, what if you needed to know volume? Well, you would divide both sides of this by density. And so volume is going to be mass divided by density. So that's going to help you get the first question answered, because if you guys haven't done that too much in 8th grade math or algebra, you may not know how to kind of manipulate those formulas. All right, so that's the first hint. Okay, at some point when I'm talking, the bell's probably going to ring, but that's just on my recording, so don't you guys worry about that. All right, the next thing, the next page, we need to look at this page. You are having to use the information on both of these situations to figure out number of protons, neutrons, electrons, mass number, atomic number, number of valence electrons, etc. A lot of that information is in the packet that I gave you, but there is also the RM12 that I posted online that's going to be very helpful. Okay, and I'm talking about this paper. Atomic number is the number of protons, remember. The atomic mass is this number with the decimal places. Remember that you have to round that off to get mass number. So don't write, a decimal, 6.94 or something like that for mass number or whatever, because it's got to be rounded off. But anyway, take a little while, a few minutes and review that. And let me say something else about this sheet. So the problems here are similar, but they're not done quite the same way. Here, all I did is I gave you a box from the periodic table, and so you have to rely on whatever information you can get from the periodic table. And unless you can see information that's going to tell you that the atom is not neutral, then you assume that the atom is neutral. So here you have to more rely on the box from the periodic table to answer all of this. Over here, I gave you a picture, a Bohr model of one particular atom. So you have to rely on the information from the picture in order to answer all of this. So just be careful there. Okay. All right. This page. AXZDEJ. First, if I didn't correct it for you, number 5 should say, what do A and J have in common? Because there is no F. Okay, so fix that. And then something else that's going to help you on this one is your color-coded periodic table. Again, I put it in Google Classroom, but I would also encourage you to listen for just a second, because I'm going to remind you about some of the columns we learned about. Column 1 are your most reactive metals. They have one valence electron. They give those valence electrons away very easily. Sodium, potassium, rubidium. Those are all the things that they put in water that exploded and whatnot when we watch those videos. Over here, fluorine, chlorine, bromine, iodine. Those are your very, very reactive nonmetals. Those are known as your halogens. Next door to them are your very unreactive nonmetals, the noble gases. So you've got the noble gases, you've got the halogens, very reactive nonmetals, and then over here you have your most reactive metals, just a reminder. And that's going to help you answer one of the questions. Okay, and the last thing I'm just going to say is on this particular page, we did this actually when we covered chemistry, but something's going on here. Sorry about that. Okay, here something's happening. You have copper powder, and it's turning into copper oxide. Well, you can't just have things magically appear or disappear. So please remember on this that yes, it still is going to obey the law of conservation of mass. And in order to write a balanced chemical equation, you need to recognize that the copper must be reacting with oxygen from the air in order to produce that copper oxide. So down here, you're going to have 63.55 grams of copper powder reacting with, I don't know, some amount of oxygen. And that's going to produce 79.55 grams of copper oxide. Remember, the total mass on both sides of the equal sign has to be the same, so you can do a little math and figure out how much oxygen you need. All right, so that does it. That should kind of help you get things figured out for your RC1 review. Again, most of the stuff is either, if it's not in the pages that I pointed out, then I helped you out with it.